Good night, everybody. Hopefully, can you hear me? Hopefully, you can hear me. And yeah, I was out for a week. I told, I mentioned that I will be studying and trying to solve some computational problem, but the truth is that I ended in the hospital the entire week, accompanying my mother. She was very ill, and I was with her the entire week. Uh, so I studied some other topics like some Java and what else? Some logic, methods of logic, some a couple of chapters. But now we are back uh, with this series, ongoing series, in order for you to see the struggle. It is a struggle, and I like the definition of science of that Judea Pearl gives about science. He says that it is a struggle, a human struggle. So only if you are a genius, you can, you know, do this with your hands crossed. Otherwise, you have to put, and in my opinion, there is not such a thing like being a genius. You just have to put uh, lots of hours practice, fail, recover, and again, try again. And we are here trying to solve this time. Let us see here. 3.19, I suppose. Yeah. Yeah, this is the one. So write a function filter. You know, these two are very famous functions. In the last episode, we tackled this map, and now we are this, defining, defining a writing filter that removes elements from a list unless they satisfy a given predicate. Use it to remove all odd numbers from a list of type int. And they give us uh, the filter type signature, you know. Let's start by doing some cleaning over here, because now there is a lot of code that, you know, we are starting to scroll the thing right here. So let's get rid of fold left using fold right. Also some, maybe we are going to need this as an example in the case uh, we forget the Scala syntax. Let's get rid of them. Let's get rid of +1 into strings. Let's get rid of fold right using fold left. We are leaving fold right and fold left because they are useful. Reverse also get to stay, then concat. And also I want to write this. In the last episode, we ended, we wrote map with this tail recursive pattern matching fashion. But if you remember, we ended seeing the solution to compare our solution with the official solution. So let's write here an A, and let's try to, to see if we remember, because they abstract the whole thing with right, and it was great. It was it was great to see that. So let's try it. Map. Now this is mapa. But this is map. This mapa is a Spanish word, and this is map. And they used fold rights. Let's see if we can, use it. And fold right. I'm not sure about this, because fold right needs an accumulator. It has to be a a new list, empty list. Now the function we in the previous episode I didn't see this abstraction, because I wanted to map to associate this arriving function with the function we are sending in here to fold right. So I wasn't able to see that we can abstract this with fold right. Now we are here again. Let's use this, because fold right. And this series is to share my thoughts, not to shine, not to perform. I'm not interested in that. Look at this, head and tail. Where is it? All right. All right. Expects a two-parameter function, head and tail. So I was thinking, and that I missed that we will send in this function. I was thinking maybe it's not possible because we are accepting a one-parameter function. But that's not the case. In the official solution, we can send to two-parameter function, a two-parameter function, and this is what they did. This function will consify, and now we have this head of type A. Look at this, into which we can apply this f to obtain an element of type B, which will be here. So f of f of head, yeah, and tail. Let's hope for the best, and don't worry if we don't get it. We can always sort to the previous version that we have. Are we missing a parenthesis? No. No map. We have this. So let us see. Seems like some error. Nothing is happening. Are we online? Let's check. 10 minutes. Yes, we are live. So what is happening? Okay, here they are. Map. So I think we were able to replicate and understand, which is important, the official solution. And now we can, see map. Where is it? Like in here. By the way, this is stack safe, and this is not. This is great. This is great. This is good. I like this abstraction. Now let's define filter, which is the topic, the problem for this session, and we already consumed 11 minutes, so I'm sorry about that. And let's copy this one. If you are in your job, you need certainly to do this very quickly, to perform, to shine. Remember, we are not in a job setting. We can have the privilege to spend the time thinking and talking out loud, sharing the thoughts, especially if you are in a job interview. You need to do this very quickly. I ended copying the type signature. The filter A. We have our own data type, a list, A to Boolean. Look, I want to call this P. It's a predicate. Okay, you can see here, there will be something similar because we have F, A to B, we have P, predicate, A to Boolean. My list. Let's what else? Okay, unless they satisfy a given predicate, use it to remove all odd numbers from a list of type int. Let's start with that. 4, 5, 6, 7, 8, 9, and 11. We have our new empty list. Now we need to filter and filter A1. We need to pass a predicate. They want us to use the filter to get rid of the odd numbers. So we will get rid of 1, 3, 5, 7. We are talking very slow. 9, don't despair. 11. If you're a genius, probably you are desperate by now. If you are a person who struggles too much with this, uh, hopefully you are getting something out of this. Out of this, okay. We are staying only with 2, 4, 6, 8, and 10. So the predicate will be number that is divisible, that is even. So we're using this syntax. Let us try this. You think this is going to work? Mod 2. Do you think this is going to work? Maybe if you don't know what's happening here, we are doing something like uh, function about breadth. You have to annotate the type. But Scala is good inferring types. And this predicate receives an x or n of type int and says that if that n is equals to 0, this is becoming this syntax. Maybe, and of course you can pass this pred over here, pred and pred. I want to try this. Why? I don't know. Okay, so we will end with 2, 4, 6, 8, 11. Now it's time for us to write a function. What can we do here? Let's take a look at the time. 18 minutes. We ended, talking about map at the beginning, which probably was a bad idea because some people see the time in a video, the length of the video, and says, I'm not going to spend 30 minutes with hearing this guy talking very slowly. I am in a hurry. I need answers. So I don't know. Okay, let's try this. Copy and paste. Because we are running out of time, we have 1 hour per problem. Again, we have our ace, we have our predicate, and we have head and tail. Now, the body of the function. We need to retain only the elements that satisfy this predicate. So we need to test for the predicate. And the first thing that comes to my mind to test for a predicate is to actually apply this if, or use this if p of x. Oh, we are naming this head, what I'm doing here. And I'm not sure if this is going to work. Head. Hopefully you are saying this. I think I'm missing something. I think I am missing something. Let if we are unable to use all right, we will sort out. We will go back to this explicit uh, pattern matching, and we will apply the if over here with where is it? With we will use pattern matching and recursion. Yeah, that's all. But but first, we need to try this thing here. We are. I don't remember if an else is needed the whole time. I suppose that's the case. I think we are going to need an else. Let's run this. But we are going to need an else. Found type B. Where is type B? Where is B? Okay. Are you seeing this? Percent for the power chart. Over a plug. Okay, look at this. Found unit. Maybe you're missing an else part for the conditional. This is great because that's the case. And what do we need to put in the else? Look at this. We have cons. We have an element of type a head, type A. Opening nothing else. Element of type A. We have a tail, type nil. And we have if. We have our predicate. Two heads. And once tail, and we are here now. So we are arriving with an empty list as an accumulator, or yeah, accumulator, which we are calling tail. And we are having this list, this 7. We have this. no, no. In the function, we have this structure. The structure, and we say if, oh my gosh, if b one, and let's suppose we are in the number two, because that's the part that we have. Ohms and nil in the case that we are starting, and we will end the it will result in something like this. If some 4 arrives, but remember that 4 rise goes all the way in, all the way to the right, like that. Now, what happens if we have 1? We don't we don't we don't need to add the element. We need to remove the element. We need to leave out that element. And how can we do that? I'm not thinking. What can we do here? And let's check the hour. 28 minutes. Do you think we will be able to do this? Okay, if a number that satisfies the predicate, we add it to the list. If not, if this, I think at the end we will be using some sort of pattern matching. I think we put in the else part. Head, I started scratching my head. If the head then comes head tail, just wandering in my mind, trying to avoid the block in the thinking process. Okay, so we have this 1, 2, 3, 4, 5, 6, 7. In the first case, we have this, which I don't think we have. This is not correct. And let's remove some elements. This is what is going to happen. This one, and you know the empty list. And the second element, 2. Let's add a number 4, and this is the accumulator. We are exercising the fold right traversal. I got it. I got it. I got it. You got it? Okay, now that the fold right have go throughout the entire list, throughout element, it will start to apply the function, you know, in order to accumulate the result. And we will say 4 satisfy the predicate. Yes, in the case for the even numbers. So we say cons have tail. Tail is the accumulator, remember. And I think it's going to be, let's use this notation. It will result on this. For the head to the tail. Cons. Now we are writing here these 3 an element that satisfies the predicate. No, it's not an even number. So we don't get to add the element to the list. So we need to return what we have already, only the 4. So it is say the accumulator. Okay. And at the end, this will be the result. Take a look once again the process that we followed, because at some point we we got some kind of blockage in the mind. But I think this will do it, hopefully. Let's pray. Okay, and let's run this. And here we are, And this syntax worked out very well. So we have 2, 4, 6, 8, and 10. We get rid of 11, 9, 7, 5, 3. Okay. And the empty list, in the case of the empty list, there's nothing to do. Wow. At some point, I thought I won't be able to deliver the solution, because this is not marked as hard in the book. Where's the book? Okay. And by the way, this is great. How many exercises? Look at this. This is great. And the solutions are all provided. So this is a great book. Uh, okay, we wrote filter. We're very happy. Be happy. Where's the YouTube? 35 minutes. Yeah. What else? Yeah, visit my website. Take a look at the other content in the YouTube channel. And if you are struggling with this, don't worry. Even if these problems are not marked like hard, they are challenging in a way because the paradigm is different. It's another way of solving problems. Okay, so see you later. Thank you very much for tuning in.